My dear student, I am Madhu Kumar. I am going to explain the force, chapter Force and Pressure. It is the 9th lesson of your book. In this chapter, we will study the following points, that are force and its cause, effects of force, type of forces, pressure, relationship between pressure and area, pressure exerted by liquids, and atmospheric pressure and its effects. Now, I am going to explain about the force. That force, we can define force as a pull or push acting on a body which tends to change its state of rest or of motion. Here, a force to move an object away from our body, that is called push, and the pull is when we apply a force to move an object towards our body. The unit of force is Newton, and formula of force is equal to F is equal to m into A. Here F will be capital, m will be a small, and A also a small. M related to mass and A is the acceleration. Here there are some examples of force. If the two forces act on a body in the same direction, the net force is the sum of the two forces. Here you can see that two forces F1 and F2 apply on an object in the same direction. Then the net force, we will add the both force. It means net force is equal to F1 plus F2. Second example, you can see that here is the two force F1 and F2 that apply to opposite direction. Then if F2 is greater than F1, then net force is equal to F2 minus F1. If F1 will be greater than F2, then net force is equal to F1 minus F2. The effect on the object depends on the net force acting on it. Here another example, if we pull a block from both sides with the same force, the block remains stationary. The forces are equal and opposite. The net force will be zero. Such a pair of forces are called balanced force. Balanced forces do not change the state of rest or motion of an object. However, can change in size and shape of the object. Effects of force on an object. Here, the force can make an object to move from the rest. Force can stop a moving object. Force can change the speed of an object if it is moving. Force can change the direction of an object, direction of motion of an object. Force can change the shape of an object. Force may cause one or more of these effects. Now I am going to explain the types of forces. A student, here there is two types of forces. One is contact forces and second is non-contact forces. Contact forces. Contact forces are forces exerted by an object and another object when they are in with contact to each other. Contact force are of two types. One is muscular force and second is frictional force. Non-contact forces are forces exerted by one object on another without any contact with each other. It means they are not coming in contact but they exert its force. Now, contact forces. First, that is the muscular force. Muscular force is the force exerted by the muscles of our body. We use muscular force of our various activities. Animals like bullocks, horses and camels, donkey, elephants also use muscular force to perform various tasks. A student, muscular force, muscles get the energy by the oxidation of glucose in the cell, And by the oxidation of glucose, carbon dioxide, water and energy is formed. Here energy that is stored in our muscles in a ATP form, adenosine triphosphate. When our body requires energy, this ATP breaks into ADP and energy, and our body utilizes this energy with the help of our brain. Second contact force, force of friction. Friction is a self-created force when the two objects come in contact. This friction force always opposes the motion. Force of friction is the force which opposes the motion of an object over a surface. Here you can see one example, a ball rolling on ground gradually slows down and comes to rest due to friction of ground. If we stop paddling a bicycle, it gradually slows down and comes to a stop due to force of friction of the ground or the road. Second, I am going to explain about the non-contact force. First is the magnetic force. Magnetic force is the force exerted by magnets. Here, when we bring the poles of different magnets to each other, there is a repulsion and contraction. First you can see the example, when we bring the different pole, north pole and south pole, the both magnets attracts to each other. Second, also that is the south pole and north pole, here is also different pole, there will be attraction. C and D example, we can see that when we bring the north pole of one magnet and north pole of another magnet, there is a repulsion. The example, we can see that when we bring the south pole of one magnet and south pole of another magnet near to each other, then there will be repulsion. Now, second example of non-contact force, that is electrostatic force. Electrostatic force is the force exerted by a charged body on another charged or uncharged body. Electrostatic force always created by the rubbing of the object. When we take the bad conductor of object and when we rub to each other, they will create a force. One object charge, both objects can be charged of the same charge or different charge. In this way, they will create attraction and repulsion between each other. Here you can see that example, a plastic straw charged by rubbing with a paper attracts a suspended plastic straw. Third, that is a non-gravitational force. Third non-contact force, that is the gravitational force. Gravitational force is the force exerted by the earth on all objects. It pulls all objects towards the earth. Here student, you know that each object which has mass, they create the gravitational force. Here the earth also create a gravitational force. The earth's gravitational force is not same on the surface. When we go to the equator, the gravitational force decreases, and when we move towards the pole, the gravitational force of the earth increases. Pressure is related with the force. It is a measure of how much force acting on a certain area. Pressure is the force acting per unit area. A student, you know that this pressure that is exerted by the atmosphere. Our earth has atmosphere, earth has blanket of air, and we know that air has mass. So air also exerts its weight on the surface, and when we calculate the force of atmosphere per unit area on the earth's surface, that is called pressure. Here pressure is equal to F upon A. It means by this formula we can say that the force or pressure is directly proportional to the force and pressure is indirectly proportional to the area. It means when we increase the force, pressure will increase. and when we increase the area, pressure will decrease, and when we decrease the area, pressure will increase. The unit of pressure is Pascal. If the area is small, the pressure will more on the surface of for the same force. Here another example how the force exert, how the pressure exert on the object. Here we take a sharp knife. A sharp knife has a very small surface area on its cutting edge so that the high pressure can be exerted to cut the onion, and it is very easy to cut the onion with the sharp knife. Second example of the pressure, increase the pressure by reducing the area. Here another example you can see the high pressure on the surface of the ice so that the ice melts and allow the ice scatter to glide smoothly. Now another example of pressure. Here we can see that increasing the pressure by reducing the area. When we take a sharp nail has very less area, and when we apply the force by this force there is a high pressure exerted or created, and the nail easily insert inside the wood or the wall. Second example, you can see that skis has a large area to reduce the pressure on the snow so that they do not sink in too far and they can easily slide over the ice. Next example of pressure, liquid pressure. The pressure exerted by a stationary liquid kept in a container at any point inside the liquid is known as hydrostatic pressure or liquid pressure. You can see through this diagram. Pressure exerted by liquid gases. Liquid's pressure on the bottom of the container does not depend on the area of the bottom. It acts perpendicularly to the base. Liquid's pressure at any point inside the liquid depends upon the density and the height of the liquid column above that point. Liquids exert sidewise pressure, and external pressure applied on a liquid in a closed container is transmitted uniformly throughout the liquid. Here another example of the liquid pressure. Pressure increases with the depth. You can see through this picture. The deeper into a liquid you can go, the greater the weight of liquid above the higher pressure. Here the pressure, the more dense the liquid, the higher the pressure at any particular depth. You can see that here is the two container. One container we contain oil and second we contain water. The density of oil is lesser than water. So here through the picture we can see that water exerts high pressure, high liquid pressure, and oil exerts little liquid pressure. So the water can fall far from the container in the case of water, but in the case of oil, the oil that is goes not far away, that oil falls near the container due to the low liquid pressure. Here another atmospheric pressure. A student, you know that air has pressure and our earth is surrounded by air. So air also exerts its pressure. When we calculate the weight of air per unit area on the earth's surface, that is called atmospheric pressure. A student, you also know that near the earth's surface the air is very dense, and as we go above the quantity of air decreases. In this way, near the Earth's surface, the atmospheric pressure is high, and as we go above in the air, the atmospheric pressure decreases. Here, student, you know that the weight of an air column of the height of the atmosphere and area 10 centimeter into 10 centimeter, that is exerted near about 1000 kilogram pressure. Now another example of atmospheric pressure. Here you can see that we contain a beaker. Inside the beaker we take a water, and here is a syringe. When the piston is pulled up, the atmospheric pressure inside the cylinder or inside the syringe will decrease, and outside the syringe the atmospheric pressure is high, and we know that the liquid or air flows from high pressure to low pressure, so the liquid easily insert or climb inside the syringe. Second example, that is of a straw. When a person sucks through a straw, the pressure in the straw becomes low, because when we suck, the air goes inside our mouth, and in the straw the quantity of air decreases, so here is the low pressure created. And outside the straw there is water, there is a high pressure, so the water or liquid or cold drinks easily increases inside the straw, and we take the cold drinks. Here now, student, you can understand the force, type of forces and effect of forces, pressure and type of pressure, that is the atmospheric pressure. Now you can understand better. Thank you, student.